Imagine capturing the most intricate, high-definition snapshot of one of the sun's most explosive events. And now, thanks to cutting-edge technology, that's exactly what scientists have done. For the first time ever, researchers have obtained the clearest, most detailed images of a solar flare, revealing never-before-seen structures on the sun's surface. But here's where it gets controversial. Could these new insights completely change how we understand solar activity? And even our ability to predict space weather? The breakthrough was made possible by the Daniel K. Inouye Solar Telescope, located in Hawaii and recognized as the world's largest solar telescope. On August 8, 2024, this powerful instrument zeroed in on the final moments of an intense X-class solar flare, the most energetic category of solar flares. What it captured was nothing short of breathtaking, chaotic, twisting loops of superheated plasma suspended in the sun's outer atmosphere, known as the corona. This is the first time the Inouye Solar Telescope has ever observed an X-class flare, said Cole Tambury, a solar physicist at the University of Colorado Boulder and co-author of the study. These flares are among the most energetic events our star produces, and we were fortunate to catch this one under perfect observing conditions. So, what exactly is a solar flare? Think of it as a sudden, intense burst of radiation and particles released from the sun during magnetic disturbances. These events are driven by the sun's complex and ever-shifting magnetic fields. When these fields become tangled and suddenly reconnect, a process called magnetic reconnection, they release enormous amounts of energy in the form of light and particles. If directed toward Earth, these solar flares can interfere with satellite communications, GPS systems, and even power grids. And this is the part most people miss. Until now, scientists had only a vague idea of the actual size and structure of the plasma loops involved in these flares. Older telescopes simply couldn't resolve the fine details. That's where the Inouye telescope shines, literally. Using its visible broadband imager, researchers were able to zoom in on individual loops with unprecedented clarity. The results, published on August 25th in the Astrophysical Journal Letters, revealed that these plasma loops range in width from about 13 miles, 21 kilometers, to around 30 miles, 48 kilometers. That may not sound like much compared to the sun's massive scale, but in solar physics, this level of detail is revolutionary. We're finally peering into the spatial scales we've been speculating about for years, Tambury explained. This opens the door to studying not just their size, but their shapes, their evolution, and even the scales where magnetic reconnection, the engine behind flares, occurs. Here's a fascinating analogy. It's like going from viewing a forest from an airplane to suddenly being able to see every individual tree. Scientists believe that these newly resolved loops might be the fundamental building blocks of larger solar structures called arcades. If that's true, then we're not just looking at bundles of plasma, we're seeing the individual threads that make up the sun's magnetic fabric. This discovery could be a game changer. By understanding the fine details of how these loops behave, scientists may be able to improve models that predict when and how solar flares happen. That's not just academic curiosity. It has real-world implications for protecting our technology and astronauts in space. It's a landmark moment in solar science, Tambury said. We're finally seeing the sun at the scales it works on. But here's a thought-provoking question. Should we be investing more resources into space weather prediction, especially as our reliance on satellites and digital infrastructure grows? Or is the risk still too uncertain to justify major funding? What do you think? Does this breakthrough change how we should approach solar research and space safety? Share your thoughts. And let's get this conversation started in the comments below. Skylar Ware is a freelance science journalist covering chemistry, biology, paleontology, and earth science. She was a 2023 AAAS Mass Media Science and Engineering Fellow at Science News. Her work has also appeared in Science News Explores, ZME Science, and ChemBites, among others. Skylar holds a PhD in chemistry from Caltech.